Moonwalking into class. Hello, everybody. Mr. Thomas here, back with another lesson, back with another chapter, chapter 7. We're starting it today. And today, we're looking at exploring exponential models. And we're looking at two things. We're looking at exponential growth and exponential decay. Now, I get really excited about this lesson because there are direct applications to your real life from this. And part of those applications involve money. So, stick around for this lesson. When we think about exponential growth and exponential decay, here's what we're talking about. When we say growth, all right, think of growth as green. The x value increases, and as the x value increases, the y value increases. When we think about exponential decay, we'll use red to represent that. As the x value increases, the y value decreases. Remember, if you have a blue box on these notes, that's something you probably want to write down in your notebook. So, exponential growth, the x goes up and the y goes up. Exponential decay, the y goes down as the x goes up. Keep that in mind. So, there's a couple ways we can identify exponential growth or decay. One of those ways is what I call the long way. And that is by graphing an exponential function. So over here we have this function, y equals 2 to the x power. So to graph this, you would need to plug in a number for x and then find the y value. So that's what they do over here. They plug in, for the x, they plug in -4. And when they plug in -4, their answer for y is 1/16, or 0.0625. Then they go and they plug in -3, and when they do that, they get 1/8. Then they plug in -2, and when they do that, they get 1/4. Now notice, as this number is increasing, okay, we go all the way over here to 1. Notice the y value is also increasing. So we went from having a very small decimal to now we have 2. And then by the end of it, when we plug in 3, we have an 8. And so to represent this on a graph, you would just plot each point. So this last point that we looked at, 3, 8, is plotted right here. This is the 3. This is the 8. And where they meet is right there. So they just plotted these, and then we can look and we say, oh yeah, as the x increases, so does the y. This is exponential growth. That's one way to identify exponential growth and decay. A faster and much easier way is to be able to identify the standard form of an exponential function, which is y equals ab to the x. Now remember, the a and the b represent numbers. All right? The x will also probably have a number when you're solving later on in this chapter and in this lesson, but for now it's just going to be an x by itself. So, when we look at this, if the b number, all right, is greater than 1, then that represents exponential growth, okay? If b is greater than 1, it's growth. Now, if b is in between 0 and 1, that represents decay. So if b is less than 1, but greater than 0, it's decay. So let's look at an example. So this is really quick and simple. You're just going to look at whatever number's in the b. It's pretty easy to identify. It's in parentheses. All right? So 0.95. That is in between. It's greater than 0, but it's less than 1. And so this represents decay. 2. 2 is greater than 1. Therefore, it represents exponential growth. Pretty simple, right? Okay. That's all you need to do for this. Just pay attention to that function, standard form of the exponential function, and then find the b and interpret it correctly. All right, so now we're moving closer and closer to that real life application. You will need a calculator for this. It could be one of these fancy ones or a smaller one. And so this is a model for something called compound interest and exponential growth. So this is the formula that you just need to know. It needs to be in the notes somewhere. So take a picture of it, write it down like this. You really just need this, but you need to make sure what each of those things means also. So it says you invested $1,000, the initial amount. So this is like if you had a savings account. The initial amount of $1,000 into a savings account. The account pays 5% annual interest. That's your rate of growth. That's how fast it's going to grow. 5% each year. 5% of this account each year is going to go back into your account. Then it says, how much money will you have in the account after 6 years? So you're just going to take these numbers and plug them in the right spot. So we want to know what the amount is after 6 years. So we can take that initial $1,000 and we plug that in. Our rate of growth is 5%, or in decimal form, 0.05. And then the number of years is 6. All right, you just type all of this into the calculator, exactly like you see it. Now you could simplify it, that's fine, but you could just type it in exactly like you see it, using the parentheses, and you're going to get 1,340 and 10 cents. Now this is saying that you started with $1,000, you just kept it in there, and then after 6 years, you added $340.10 just by keeping it there. That's one thing that's cool about this, and we're going to look more closely at it here in a little bit. Okay, so now, how do we do this without the help of it walking through each step? So you're going to have your formula, and you can write your formula out like this. A equals, some number is going to go right there. 1 plus some number, and then another number is going to go right there. So I have an initial amount of 500. So I'm going to put that as 500. That looks like an S. There we go. And then it's going to grow at a rate of 3.5%. Now in decimal points, that's 0.035. Then the amount of years that I'm keeping that in is 5 years. So I would take my calculator and I'm just going to type this in exactly like I see it. I'm going to hit 500 parentheses 1 plus 0.35. I'm going to hit that little, there's like a little carrot stick button, that's what I call it. That will allow me to do my exponent of 5. And then my answer is $593.84. Something like that. All right, pretty simple. So, there you go. This last slide for stats, which is a math class you will take next year, possibly with Mr. Britt. You're going to do more with graphing calculators, and you'll be able to see, like, basically, you can try to use this. We won't necessarily need this for our class or for our assignment, but this will show you, like, how much you'll have after a certain amount of years. You don't have to worry about this, but you can mess with it if you would like. So let's look at our assignment has 6 total questions. You should be able to work through it with no problem. Now we're about to transition, so that's the lesson. So if you only care about the lesson, then you're done. I will see you in class. However, if you would like to learn a little bit more about rate of growth and compound interest, I'm going to make another video showing you how to do this. So please check that out. But this video is the one you need just for your lesson. You don't need this for anything else, okay? I will make another video going over this. I may do it like on Zoom or Google Meet or something like that, so that it's a little bit easier for me to navigate the buttons. But great job. I will see you all in class, hopefully all of you, before the end of the semester. Maybe Ms. Colette and I will join classes, but have a great day. Goodbye.